All right. Hello, everyone. This is AP Physics 1 tutorials. Um I'll probably be answering questions about the lab and the test review for next week. Um, any other general questions before we get started? So, one of the questions already was why is there another spot to submit the assignment for the College Board assignment due today? That's because some people turned it in and their score got locked. So I added another assignment that they can work on, and that way they're not completely locked out. So if you didn't turn in the first one, you can just finish it there. If you did turn in the first one, you can go to the other spot. And on the College Board assignments, you don't have to turn it in. I can automatically turn it in for you. So if there's no questions on general things, then any questions on the lab and or assignment? Problem with Google Classroom. You can't go to Google Classroom on your iPad. The iPad might be forcing you to open it in the app. Do you have the app? And it's not letting you open it up inside the app? Yeah, if you turn in one of the assignments on College Board, then you don't have to turn in the other. You just need one. It's not letting you. That's strange. Is anyone else having the problem where it's not letting you get into Google Classroom on your iPad? So it's is it not letting you in just like in the browser, or it's not letting you in the actual app itself? Yeah, what might be happening with that? I have no idea. This is just a complete guess. Uh, it might be that there's just so many people using Google services recently and Google Classroom all at once and uploading so much that it might just be reaching bandwidth limits. Uh, I know a lot of companies like Netflix, YouTube, Facebook have been having to slow down the bit rate of their video services because so many people are using it. So it's a possibility that just so many people are using the G Suite, the Google things from our school, and we only have so much bandwidth dedicated to that that there might be issues with it. So if you're having issues with it, you might check back outside of hours. Yeah, just 1 hour for jeez. So you might try at some off time, like really early in the morning or late at night, and it might let you turn it in. Um, yeah, just let me know if you ever have extreme difficulty turning something in. Uh, I prefer you not email it to me. If it doesn't work out, then you can as a last resort, but just try at a different time. I don't know what to say other than that. I just assume it's an overuse issue. Any other questions? Uh, oh, wait, why is this not? Wait. No, you don't have to do the other College Board assignment if you finished one of them. I just did that for people who turned it in and couldn't get back onto it. Uh, that's weird that it's just a school iPad. Um, Do y'all have more than one computer, or are you having to share your computer with other people? Because if you're able to just use a computer, obviously that would be preferred. Yeah, I have no idea why the iPad would be messing up. Are y'all allowed to get a different web browser on your iPads, like Chrome or Firefox? Actually, probably not Chrome, because Chrome is Google and it's just going to force you through the app. Yeah, Chrome is pretty terrible at forcing you into the app they want you to use. Uh, you might try to get into it from the browser. Maybe even the default Safari browser might let you in. I don't know, just guesses. But yeah, if you're able to use other sources, then use those. Unless you're having to share everything, you just kind of use what works for you, and then tell me if anything doesn't work. So yeah, that's probably the biggest thing. If anything is not working and you're having difficulty turning something in, just let me know. Uh, I'll work with you on that. I'm not going to immediately count something late if you struggle to get something turned in. So try not to stress so much about that. All right. Any questions on the lab and or the review? Part 2, question 2 on the lab? Yes. Part 2, question 2. Yeah, so that's the one talking about the radius of the Earth. So we have the radius is 6,371.865 kilometers. But this is only to sea level. But yeah, I actually looked it up. Garland is 168 meters above sea level. Uh, yeah, if you're able to get one person, that's okay. I just want y'all to try to collaborate on this because we might be out for a longer amount of time, and I don't want everyone working individually. So yeah, if you're only able to find one person to work with, that'll be okay. All right, so we're trying to figure out how far is the pendulum above the center of the Earth. What do I do with those two values? You can add them, right? Can we just directly add them? Convert kilometers to meters. So times 1,000 meters. So yeah, that's all 2 is saying. So convert this to meters, and then add that value to this value, and then you get the correct value for how far the average person in Garland is above the center of the Earth. Um, Another thing that people kind of mess up on this one is just that next part 3. It's just saying set FG equal to FG. It's just saying set mass times acceleration due to gravity is equal to the gravitational constant, mass of the pendulum, mass of the planet divided by r squared. Other questions? don't know why the screen is frozen. What's your question? Does latitude affect anything? The latitude actually does. The Earth is slightly wider at the equator, but the latitude was already taken into account with that 6,371.865 kilometers. So the latitude would affect things, but I already accounted for that for you. Also, you can unmute your microphone to ask a question. That way I don't feel like I'm going crazy just talking to like a wall of text in front of me. Then the voices in my head will become reality.
So for the graph,
Yes.
what's it called? Uh, okay, so it's at equilibrium, right? So I did the friggin' spring force is equal to force of gravity, like versus the distance. Would that work as like a good graph for the beginning part of? Let me wait. Give me 1 second.
Yeah, you're on number 2, right?
Yes.
Yeah, so your spring force versus that displacement from equilibrium, exactly. And then which one are you putting on the y-axis?
Wouldn't spring force go on the y-axis?
Yeah. Spring force, displacement, because y divided by x, spring force divided by displacement is going to equal your spring constant.
And then there's another part of the graph. I mean, part of the question which says you could also use the graph to find the what is it? The energy stored in rubber band. So we only need one graph, correct?
Yeah, so for 2, you're only using one graph. You'll have a different graph for 4, though. 4 is going to be a new graph.
Okay, okay.
And I didn't tell you what to graph for 4. But 4, you're trying to create a graph using the period of a spring. It still is kind of spring-like. 2 pi square root of mass divided by spring constant. So you're going to solve this equation for spring constant, and then you're going to use that to figure out, well, what's in my numerator? I'll put that in my y. What's in the denominator? I'll put that on my x. All right. Part 2, number 6. Well, that's kind of everything we ended up having to measure for this one. So just think about what things dropped out of your equation as we went through this. So I don't want to tell you everything about it, but yeah, setting up your equation. I mean, I'll give you a hint. If you see something like this, like mass of the pendulum divides out, do I need to measure the mass of the pendulum? No. So we don't need to measure the mass of the pendulum. We're probably using our pendulum equation. Period of a pendulum is 2 pi square root of the length divided by acceleration due to gravity. So what are some things I need to measure? We're trying to get acceleration due to gravity, so what do I need to measure?
The length of the pendulum and the time it takes, the period.
Probably need the length of the pendulum. And what do we use to get length? Yeah, meter stick ruler. So measure length with the meter stick. Probably want to get period of the pendulum. Probably want this value. That radius is going to be the hardest thing to actually measure if you're trying to do this practically in the real world. This is a constant, so I don't need to measure a constant. So yeah, just things like that. That's kind of a setup to a lab type question I could ask you on the test, or College Board could ask you on the AP test. What else? So any more questions on the lab?
Can you please go over to be about the energy graph, please?
2B. Okay, so energy is stored, and the rubber band for the different masses. What was this? 1, 2B. All right, so we created that graph. We have spring force versus displacement. Now, if it's a perfect Hookean spring, it should be a straight line. Yours, there's a good chance you're probably going to see some sort of, let me see, what is it probably? You're probably seeing some sort of curve. Is that the way it would curve? It would have an increase. Actually, you probably see a curve like this. But yeah, we're going to assume it's a straight line. Try to make your best line of fit. So there's a few things I can look at on the graph. I can look at the area between the curve and the x-axis. I could look at the slope, y divided by x. Area is y times x. Or I could just look at a certain point. What is my spring force at a certain displacement from equilibrium? So getting energy, am I just looking at the force by itself? Do I want to do force times distance, or do I want to do force divided by distance? All right, so I need to multiply times. So work is the whole change in energy is force times distance. So I need a force times distance. Displacement will work as distance here because we start at 0 and then we move away. So displacement will be the same as distance because we're not moving backwards at all. So when I do area, so that's going to be base times height. Well, we have a triangle here. So 1/2. Our base is displacement in the x direction. Our height is our spring force. So that should be it. So this is all we really end up having to do. So we'll draw our best fit line and we'll choose 2 points on here. So let's say where it says at 87 gram mass, we'll figure out what the force is for that 87 gram mass, predict where it should be, and figure out the area of this triangle. And we can go further and kind of prove that this even works a little bit more because I know spring force is spring constant times displacement from equilibrium. So this would be 1/2 times displacement times spring constant times displacement. Displacement times displacement, 1/2 spring constant times displacement squared. So that means the amount of work done to stretch this out is going to equal to my spring potential energy. So say for the one, 256 grams. find the weight for that thing. So 0.256 times 9.8.
Wait, so to A and B, we both use the same graph, but solve for
2A and
value.
2B is going to use the same graph.
Yeah.
So yeah, overall in this lab, you'll have two different graphs. One graph for part 1, number 2. One graph for part 4, part 1, number 4. Any other questions?
So for part 1, number 4, do you mean like 6 coin on a container or 6 different coin each time?
Yeah, so each time I added coins, that's a different mass. So I think I started with 16, and then I went to 24, 32, 40, 48. So just the ones that I did, you'll go through, you'll see how far it went from. Actually, no, period. So we're going to figure out the time and then just try to look for there and back time for just one of them. I know it's not the best experiment. But yeah, so the different amounts of coins I used, yes, those are going to be your different masses. And again, we are looking at this equation here. Again, you want to solve this equation for spring constant. And make sure when you get rid of the square root, when you square everything, you have to square your period, but you also have to square the 2 pi. So this is going to go to 4 pi squared when you square everything, right? And once you solve for spring constant, you'll get spring constant equals some value, and then you can just put the top of the fraction on the y-axis and the bottom of the fraction on the x-axis. Other questions? Is the force of gravity always equal to the spring force in the nickel spring experiment you did on Monday? So for part 1, where so we had our spring and then I put the mass in there and then the container went down a little bit. Then I added more masses, the container went down. Part 1, when the thing was just sitting there, the container with nickels just sits there at rest, then yes, the spring force is equal to the force of gravity. Part 2 is a lot messier because it was going up and down, so those forces were only balanced when it went through the equilibrium position. So if the hanging mass is just sitting there, staying at rest, the forces are balanced. Was everyone able to find a group okay? Yes, I only used nickels. Yeah, so it will gain more restoring force. So as I add more nickels, the weight of the container went up, which means the spring force went up in order to keep the forces balanced. So you are going to have different forces, so your spring force is increasing to balance out the increasing weight. Yeah, the individual objective, you don't have to use the things I use. You could just say you use a mass set, like the things we have at school, or just anything with a mass. Yeah, it doesn't need to be nickels. I was just using what I had lying around in my house. Yeah, I have a few springs. They just didn't work very well. So the individual objective, you're not actually testing this. It's like the AP test. You don't actually have to build the uh, equipment and test it. You're just saying what you would do if you had those things. So we're using things that you would commonly find in a physics classroom. So in a physics classroom, there's going to be some springs in there. There's going to be masses. You might have washers. So just anything that we normally would have in a class, you can use in your procedure. And on the AP test, again, the procedure, you don't have to be extremely detailed. You can say just something like, add 10 grams to the hanging mass, measure the new displacement of the spring from equilibrium using a meter stick. Just things like that. What do you measure, and what do you use to make the measurement? So if you're measuring time, use a stopwatch to measure time, things like that. Things you can find in a normal physics classroom. I mean, you can find. I mean, the normal physics classroom that's like string is normal, mass sets, timers. You use video. You can say record a video of the procedure. You have meter sticks, random things like that. Photo gates. We didn't use photo gates so much, but we even have a few new things like those the Bluetooth carts that you rolled along the track that automatically fed data to your iPad or Chromebook. You could even say use something like that. But the big things that you're going to measure is measure length with a meter stick, measure mass with a scale or a triple beam balance. You don't have to remember the word triple beam balance. Just say measure mass with the scale. You can even say an electronic scale. It doesn't have to be what I have in my room. Measure the time with a timer. Pretty much everything else can be derived from that. Mass, distance, and time. Is part 2. Yeah, part 2, question 7 is a bonus. It's not too difficult. This is actually not to find the maths, but I think it was like around 1000 BC in Greece. Not Greece, Alexandria, northern Africa and Egypt. They were able to solve for the radius of the Earth and the circumference. So that's kind of what this is based on. They read a book that said on this specific day when someone looked down in a well, there wasn't a shadow. They waited for that day, and then they looked and they realized, hey, there is a shadow. and then they use the two values to calculate the circumference of the Earth, which is pretty crazy given that there was no such thing as algebra or trigonometry at the time. They were doing it all with geometry, and they were off by like less than 10%. So yeah, it's kind of like that. So one place doesn't make an angle, the other place does make an angle. Draw your picture, draw the arc length of 1,000 kilometers, and use trigonometry to solve for the radius and circumference of the Earth. But yeah, seven is a bonus.
So 7 is optional, right?
Yeah. I just like 7 because 7 is something that you could go out and do today. Like, if you really wanted to, you could go outside with a pendulum, only know the length of the pendulum, let it go for a while, time it, measure acceleration due to gravity, just wait for noon, put a stick in the ground and measure the angle, and then drive like a few hundred miles south, and then put a stick in the ground at the same time the next day, and you could measure the mass of the Earth yourself, which is pretty cool in my opinion. A vertical pole? No, you're not at the North Pole. In fact, one of those is probably going to be at the equator. But I mean, if we're looking down from above on the Earth, a person, wow, that's a bad circle. A person standing here would think a vertical pole is like this. A person standing here would think a vertical pole is like this. And so if we have the light coming in from a star, if this one doesn't make an angle, and then this one makes an angle, I think it said 20 degrees, right? Yeah, 20 degrees. Then you can use these two values. You know your arc length is 1,000 kilometers, so we can figure out our radius from these two values. But yeah, it's probably not going to be the North Pole unless you have like a really weird planet. Like, what's the one that orbits on its side? Is it Uranus that orbits on it, that rotates on its side? But yeah, that actually doesn't matter whatsoever. So we're right here, and then this is here. Radius equals what? Circumference equals what? Which angle is 20 degrees? The angle from the pole down to the ground is 20 degrees. This angle right here. Could draw that a little bit bigger. So someone decided to build a giant pole that's large relative to the size of the planet, but the shadow is right there, and so this angle right here is 20 degrees. And again, you have the advantage of algebra and trigonometry to help you. And I don't want to say too much, otherwise it turns into actually a really simple question. Yeah, 1,000 kilometers due north, so someone was just standing on the equator and then someone drove 1,000 kilometers away and they saw a 20-degree angle. Other lab questions.
Wait, was the pendulum mass given to us already, or we have to solve for it too?
I did not give you the mass of the pendulum.
So we have to solve for it, right?
No. What happens to the mass of the pendulum?
Wait, because the gravitational force equation have two masses, right?
Yeah, so what happens to the mass of the pendulum?
It got canceled out.
Yeah, so does the pendulum care at all what the pendulum mass is?
Nah.
No. And again, it's just because it's falling. Anything in free fall or being pulled down by gravity, the mass is not going to affect that. Yeah, so that's the other like really cool thing. You could just land on a random planet, pick up a rock, tie it to a pendulum, let it go, and just with one other person being a certain distance away, you could calculate the mass of that planet. Yeah, by the way, this lab, you should be able to get a really low percent error. Like, pretty easily below 1%. Question 4, part 2. Are we solving for the pendulum mass or the mass of the Earth? 4, part 2. Wait, where? Which one? Yeah, so you're solving for the mass of the Earth, so you're trying to solve for capital M. So the experimental part is because you got your period experimentally. The length was measured experimentally. 2 pi is just a constant, so we get acceleration due to gravity experimentally. Then we plug in our acceleration due to gravity here. We have our gravitational constant, that's 6.67 times 10 to the negative 11. Radius of the Earth, that was not experimental. That was, I just gave that to you, so this is the only thing that we didn't solve experimentally. But because this was experimentally found, that means the mass of the Earth is found experimentally. So it's just using this equation to find the mass of the Earth. Anything else? We also use question 6. Yeah, so 6, you don't have to actually show work for that. Yeah, you're just pretty much like we're seeing in those circles. Like, those are the things that you need to measure. Yeah, exactly. So all the things that we measured here to solve for it on this, I'm pretty much just asking you to put what we did into words in a way that would get you points on the AP test. But yeah, it's pretty much it's almost just summarize what we just did. So yeah, you'll measure the period of the pendulum, you'll measure the length of the pendulum, you'll solve for acceleration due to gravity. And again, anytime you measure something, what are you using to measure the period? Well, I'm using a timer to measure the period. You could be even more specific. You could say, take a video of the pendulum moving with the timer in the video. Yeah, so you're creating a procedure for, what's that? For question 6 for part 2? Yeah. Yeah, it's just a procedure, yes. for the lab. Did you already go over 2B? Yeah, 2B. I talked about that a little bit. 2B is the same graph as 2A. Again, spring force and displacement. We have a few things. I can either just look at what's my spring force at a certain displacement, or I could look at slope, or I could look at area. Well, work is force times distance, so I probably want to multiply these two values together. And if I'm multiplying, that means I'm probably looking at area. So base times height. So we're trying to figure out a value at certain points. So let's say that 87 gram mass, we'll convert that to kilograms. So 0.087 kilograms times 9.8 meters per second squared. So we'll figure out what force is acting on this, and we'll find that value. So once I have this force at this distance, then I can just go in and find the area of that triangle there. And we see this works because 1/2 base times height, 1/2 displacement times spring force. Well, spring force is spring constant times displacement. So substitute kx in here. So 1/2 displacement times spring constant times displacement. Well, that's 1/2 spring constant times displacement squared, which is my spring potential energy. So yeah, 2B, we're using the graph from 2A. So 2A and B are the exact same graph, but 4 is a new graph using your period equation, the 2 pi square root of mass divided by spring constant. You're welcome. Any other questions? I assume people are just more stressed about the lab because it's due sooner, but also make sure you're working on the test review. And then, yeah, test early next week. Probably, I don't know, it'll be Monday or Tuesday. I have to talk with Lambert when we're going to put it out. How are you taking the test? We've been through, test review is on College Board. You might have to go to a separate spot. This one is under the progress checks. I don't know what your side looks like, but yeah, you got to sign the progress check for Unit 6. Yes, Unit 6 progress check is the test review exactly. And then how you're taking the test? Probably it's going to be through Google Classroom. I've made a system that I think we're going to use where it's going to be randomized based on different things. So you're all going to have a slightly different test. So it'll be obvious if you're copying someone, and I could even track down who you copied from. The time part is really difficult because so many teachers have things overlapping. They're saying not to time things. Probably what's going to happen, Lambert and I still haven't come to a consensus, so this could still change, so don't take this as like end all be all. It's probably going to be like a good portion of the day that you're allowed to take it. Yeah, I don't know. Probably it's going to be like 1 day window to finish it. Because yeah, ideally it would just be a set time and you start and then everyone does it at once and then it's over, but it doesn't look like we can really do that. And then, yeah, so it looks like what College Board has said right now. I mean, here, let's just pull up the College Board thing right now. Yeah, so remote learning. Yeah, it looks like so students will take a 45-minute online free response exam at home. So only free response. So that means this upcoming test is only going to be free response. The yeah, it looks like there's 2 testing dates. I think it sounds like one is going to be normal, but again, they said they'll more testing details by April 3rd. I assume the first date is going to be as close as possible to the original May 7th date, but I don't know. We'll know on April 3rd. Yeah, 45-minute online test looks like at home. It's possible if we do go back to school before then it'll probably still be like this, where it'll be on a computer. You just might take it on a computer at school. I'm not sure. We'll see. Honestly, with how things are going, I think there's a good chance we're not back by then, but I don't know everything. So yeah, we'll see. There's a good chance we're not back by then. Yeah, some schools have already closed for the year. When you look at what like China, the thing got really bad or they announced to the world on December 31st. And what's the day? March 24th. And some cities are just finally reopening. So it looks like 3 months if you completely quarantine and shut everything down, which we didn't do. And we're still not doing that. So it's probably looking like 3 months at a minimum for us. But these are just my guesses. So again, don't take my word for anything. But yeah, I assume that there's a really good chance we're not back by then. But you never know. I've been known to be wrong consistently. Yeah, I think that there's a solid chance we're not going back this year. Yeah, it is what it is. I mean, I could be wrong. If we do go back, it's probably going to be late April, sometime in May. But yeah, we'll see. Yeah, we'll go through now. It says where is it? Yeah, it sounds like taking a photo of handwritten work will be an option. I'm pretty sure they're going to uh, really, really try to prevent cheating. I wouldn't try to pull something if this is what we do and it is online. Please don't try to just pull something up and copy, because then you're just going to get disqualified and they're just going to say plagiarize. And they probably will make you sign some sort of honor statement. So I think there could be a chance that if you sign that and then you go and cheat, then you plagiarize, they might come after you for other tests also, like SAT and other AP tests. So I wouldn't try to cheat like that. So just please don't try copying directly from something. I also think you're probably going to have completely different test questions. So there's a good chance that you can't just take it and call someone up and or text and ask what's happening. So yeah, please don't blatantly cheat and get caught and really mess yourself up. And then pretty much every AP test you have this year is a shorter version. So yeah, we're not doing the last 3 topics. So we're not doing anything about waves and sound. We're not doing anything about electricity or circuits. Yeah, there's a good chance they'll record you, which I don't see how that would stop you from cheating, because currently, you could be recording me right now, and I have this entire TV behind me. I have 2 TVs right here that I can pull up whatever I want on it. I don't see how recording you is going to actually work, but yeah. It's also a thing. I know a lot of people hear, at home, so open book or whatever, and then they think that they don't have to study or remember things. And I would say that's a bad way to go about it, because that is just going to lead to a lot of looking up that's just going to waste time. so I wouldn't just look that. Yeah, so in the text box, it sounds like they might have something where you can draw on it. Uh, yeah, it's not going to be a lot of time to sit there and like read through the book to try to figure things out. I assume, yeah, 45 minutes is really fast. I think that's why they made it so short, so you can't copy. Like they're pretty much thinking, I'm just going to throw 3 questions at you at 45 minutes is my guess. That way, if you try to copy, you're going to be like 20 minutes in before you have any idea what's going on with one of the questions. So yeah, I wouldn't bank on just being able to. I can just read through my book and figure out what's going on in this amount of time. That's probably not going to happen. They said, or where was it? I lost track of it. But they said it sounded like they would take people taking a picture and turning in the test. So if it's a free body diagram, they might let you just take a picture of it and then upload it that way, or they might have some sort of system where you draw on your screen with a mouse or your finger on like a touch screen. I honestly have no idea. We're waiting until April 3rd, and then hopefully they put out some information about that. But yeah, I don't know. Yeah, here's where students will be able to take these streamlined exams on any device they have access to, computer, tablet, or smartphone. Taking a photo of handwritten work will also be an option. Yeah, I honestly, I don't know. This is a thing that we'll see. Yeah, that is another good point. If you take a perfect picture, it might take a while to do it, but yeah, I don't know. Well, I think that's most of the questions for the lab. Are there any other questions on the lab or homework, or am I okay to stop recording? One more question. What's the question? For the mass, yes, you do need to include the mass of the hanger. I think that was like the mass of 2 dimes plus the mass of nickel. So you will include that mass, yes. Do we? Yeah, after the test, there are a few things. I like circuits, so I'm probably going to cover that after the test. That will also be helpful for the next topic. I might try to do kind of a crash course on waves. But those are, I know Lambert is stressed about that because he's going to get a lot of students in physics 2 and C that aren't as ready on those. So I'll probably try to do some like easier assignments based on that, not because after the AP test you'll have worked so hard all year. I'm trying to give you all a little bit of a break. So I'll probably do some easier assignments based on that and some like quick things to go through. So we'll see what happens with that when the test is and all of that. And then, yeah, if you have questions, feel free to email me. I've been trying to respond to emails more frequently. So yeah, any questions you have, ask. Some of them I've been responding to within like just a few seconds or minutes. You can type your individual objective. Yeah, that's fine. You can type any of this and turn it in. That will work. Yeah, if you ask a question that requires a lot of calculations, you can do it in tutorials. Like I think you had the question about the one where it was launched from the top of the building, right? You're asking about that one, where would it go the furthest? So it's like this, launched like this. So you were wondering what angle we should launch that from. Well, what's the best angle to launch something from a level surface? .45 degrees. So level surface to level surface, I want to launch this at 45 degrees. This is actually the most efficient path no matter which area we launch from. So I can imagine right here, if I followed that 45-degree path, if it launched from 45 degrees here, once I get to the top of the building, we're going to have some angle that's less than 45 degrees. And so this angle right here is going to be less than 45 degrees, but the angle is going to be greater than 0 degrees. So we want some angle between 0 and 45 degrees in order to get somewhere along this most efficient path of motion. I wrote a proof of that somewhere, but yeah. And you can imagine, obviously, it has to launch up because we want more time in the air. The 45-degree angle is going to go here, and it's going to efficiently get to this point. But once it goes past that, it's falling down too much. So the nice thing about this is it keeps going sideways, but by the time it gets here, it's still going sideways with more speed. And so, yeah, it just ends up being that one. All right. I think I'm going to finish recording right now.